Let's do b now. Okay, what do we got? We've got z to the 5 equals I. How interesting. So we'll write that out in polar form. That's 1 cis pi on 2, because you know that I sits on the y-axis, which gives an angle of pi on 2, plus 2k pi, where k is any integer. By the way, don't forget to write that bit there. The k is an element of z, otherwise you'll have marks taken off you. If we just write that in that form, it makes it a little bit easier for us to work with later on. Therefore, z would be the fifth root of 1, which is 1, times this whole thing divided by 5, which is pi into 1 plus 4k divided by 10 now, instead of being divided by 2. You get it, don't you? Okay, now, if k is 0, we're just going to go through the motions now. We'll go 0, 1, 2, 3, 4. So if k is 0, z1 would be cis pi on 10. If k was 1, z2 would be, applying this formula with k as 2, we get 5 pi on 10, and that is the same as cis pi on 2. If k was 2, we'd get the third root, would be cis of 9 pi on 10, cooking along well. If k is 3, we've got z4, the fourth root would be cis 13 pi on 10, which we need to put that in principal argument form, which would be cis of minus 7 pi on 10. And by the way you do that is you just subtract 2 pi from this number, okay? And then you'll get your answer. Okay, k is 4, we get the fifth root, cis of 17 pi on 10, subtract 2 pi from that. To put it in principal argument form, that would be minus 20 pi on 10, which would get a cis of minus 3 pi on 10. Okay, that's beautiful. If k is 5, we're going to prove that they're starting to repeat now. The sixth so-called root would be cis of 21 pi on 10, which is the same as, take away 2 pi from that, we'll just get pi on 10, which is this one. Again, so this is a non-solution starter. It's just a repeated one of when k was 0. Okay? Yes. Now, we're going to do the old Argand diagram trick. It's pretty beautiful. So, let's go. There's z to the 5 equals I. And here is our first of the fifth roots, okay, of I. That is, z1 is cis pi on 10. There is z2, which is cis pi on 2. That was this little baby. Okay, then we've got z3 was cis 9 pi on 10. That was this one. And z4 is cis of minus 7 pi on 10. And z5 is cis of minus 3 pi on 10. Isn't it beautiful? Really beautiful. And they are the fifth roots equally spaced around the Argand diagram, and they are 2 pi on 5 spaced apart, the angles between them. So the coefficient of the that term there, well, that term itself is not real, therefore we're not expecting the conjugate root theorem to apply. Even though they are equally spaced around the Argand diagram, the roots are not either real or complex conjugate pairs, and you can see that there's no reals at all and there's no complex conjugate pairs because we don't have anything reflected around the x-axis, do we? Okay, number C now. We've got z squared is 1 plus I. This is a quadratic one. We'll use the old Demois trick here to solve this because this is our A. Okay, this is our A. Z to the n equals A. No problem. Now this one here in polar form is root 2 cis pi on 4, and we'll add the 2k pi here where k is any element of z, any integer. I've just put that in a little bit easier form to work with. Now we're taking the square root. So z is the square root of root 2, if you like, times cis of that thing divided by 2, which now makes it over 8. So if k is 0, the first root z1 would be 2 to the quarter cis pi on 8. If k is 1, then the second root z2 would be 2 to the quarter cis 9 pi on 8, which we need to put in principal argument form. So subtract 2 pi or 16 pi on 8 from 9 pi on 8, you'll get minus 7 pi on 8. So we get 2 to the quarter cis minus 7 pi on 8. And we don't need to go any further because we're just expecting the two roots. And I'll just start repeating if we do. Here's our nifty Argand diagram, and we're going to show you the big picture here, the beautiful picture. There is z squared, which is 1 plus I. We've got root 2 cis pi on 4. Root 2 is about 1.4, so I've got that roughly right, and the angle being pi on 4 from the positive direction of the x-axis. Okay, now there is our first root. Z1 is 2 to the quarter, or the square root of root 2, times cis pi on 8. So the angle is half, and the length of the radius is the square root of it, of root 2, yeah? And here is our diametrically opposite cousin, the second root. Z2 is 2 to the quarter cis minus 7 pi on 8. And as you can see, the angle between them is pi. They're equally spaced around the Argand diagram, so there being only two of them, they'll be pi apart. Yeah, there it is. It's lovely, isn't it? And the coefficients were not real because, have a look again, see this number here is not real, 1 plus I. So we're not expecting the conjugate root theorem to work. And of course it doesn't, because the roots are not real and there's no complex conjugate pairs. We've got nothing reflected about the x-axis, you see? That's how she works.